Whenever you are doing some calculation, please mention D if you want the degree sign values. Likewise, cos D, likewise tan D also. Okay. Okay, so these were the trigonometric functions which are predefined for Matlab. Sine, cos, and tan will give you radian values. Sine D, cos D, and tan D will give you the degree values. I hope I'm clear. Okay, let us just go to the next type of operation, that is logical operations, or I would call it logical operators. So we have logical operators in Matlab, and they are and, or, and not. Okay, let me just enter something here, magic of 3, and I'm putting semi-comma because I don't want to see my result. I know what is going to be the answer. So I'll put an echo suppressor here. Echo suppressor means it will suppress the output, save the output in workspace, update it, but it will not show me on my command window. See, let me just use I of 3, and again the semi-comma here. Where is the answer? B is equals to 100, semi-comma 0, 1, 0, semi-comma 0, 0, 1. This means it is creating a unity diagonal matrix. Okay, if you want to see what is the answer, just write B here, and this is the answer. Unity diagonal matrix. So I is a predefined function which will give you the unity diagonal matrix. Okay, so next thing, we were using logical operators here. Logical operators means and, or, and not. So let me use A and B. Enter. It will again give me a logical array as an answer. And what is the answer? Let us just see here. 8, 1 means both have some input. Answer is 1. And 8. 1, 0 means one input and another is 0 input. So output is 0. This is satisfying AND gate. Here, element wise, it will check and give you answer as in logical array. Logical array means 1 means yes, 0 means 0 means no. Okay. All right. So next is OR gate. I'm using this OR sign and enter. OR means okay, everything is 1 here. Why? Because we have at least one input in A. Okay. OR solution means it should have one input at least. Okay. So we have this logical array 1, 1, 1, and if I want to use not, this is the sign for not in Matlab, not of B, and B is my I matrix. Okay, press enter. It will reverse everything because not gate will complement your answer. 0 becomes 1 and 1 becomes 0. Again, a logical array I get. I hope you get it. The logical arrays. And next is let us do some indexing. Indexing on matrix. Okay, there are two types of matrices. One will be row matrix, or we usually call it as a row vector. Second is my column matrix, or it is known as column vector. So let me just give you example of a row vector. How can I use row vector? This is my row vector 7 and 8, and you can extend it. Enter. So what is the size of this array? I can use my predefined function size of A, and you can save it. Let's say I'm saving it in M. So the size is 1 cross 8, means 1 row and 8 columns. Okay. And another thing is, let me just use, instead of comma, I'm using semi-comma. Okay, now see the size of your matrix. Size of A, and put in N, and 8 cross 1 means 8 rows and 1 column. Okay, so these were my matrices, row vector, or we usually call it as a row vector and a column vector. Okay, so whenever we have a two-dimensional matrix, we usually call it array. We call it array. So I have already shown you how we can enter the array. Here I'm only using magic to get my matrix because it saves my time. All right, so this is my matrix of magic 6 cross 6. Here, let us just assume that I have entered this. Okay, and this is my very important data. By mistake, I have written 32, but the value was 13. The value was 1, 3. Okay, by mistake, I have entered something wrong here. So what I can do? Should I write my data again? Should I enter my data again? No, I will go to that position and change the particular value. So how we can go to the particular value of any matrix in Matlab? Enter A, because A is my matrix. Small brackets. Which row? It's a second row. Okay, and it is a second column. Second row and second column. 2 comma 2. 42. And if you want to change the value, just put equal to a square bracket, and it was 13, not 32. In matrix, in your parent matrix, you could say the value will get changed here. All right, understood? All right. So next is, if I want to change my submatrix. Submatrix means I want to change my 33, 17, and 10. These three values. I want to change these three values. How can I do? I can just write A for 33, fourth row and third column. Fourth row and third column, and let's say it should be 10. Okay, 10, but for 17, again I need to write the command. For 10, again I need to write the command. So it is very time consuming. Instead of this, we can use a operator here, that is colon operator. This colon operator in Matlab. Before explaining that, we were doing previously that we were changing these three values one by one. By using colon operator, I'm going to do this with one step only. So for that, I am explaining what is colon operator. Let me just use 1 colon 10. This shows 1 to 10. 1 to 10 means from 1, you're going to write every value 1, 2, 3. Like you're going to write a series, okay, by using colon operator. That means 1 to 10, lower limit, colon, upper limit. And by default, it will take interval of 1. Step size also we call interval or a step size of 1. Okay, so if you want to change the step size, 1 colon 0.5 colon 10. 0.5 is my step size. Step size means equally like separated values in the series. So here 1, 1.5, 2, 2.5 and so on till 10. So lower limit is decided, upper limit is also here and the interval is also here. So this is how you can write your series with a particular interval. So this is a use of colon operator here. So I'm going to use my colon operator concept here to change the values in one step. These three values I wanted to change. Let us just see. It is fourth row. All the elements are in fourth row and columns are third, fourth and fifth. So how I'm going to write here is a fourth row, third to fifth column. Always write row first. Always mention the number of rows first, then comma, then the number of columns. Okay, and just take them out. Yes, this was the value 10, 17, 10. 10 we just changed in the last step. Okay, so I'm going to change here by using equal to and new values. Let's say new values are 100, 100 and 100. They could be different also. I've just taken for example. So, okay. So 100, 100, 100 in one step. So this is known as positioning, or this value like row, comma, column. We are mentioning rows and columns. So this is known as subscript value. Subscript value of your matrix. Subscript value includes your row number or the column number and whatever you want to do. You want to take that portion out or you want to change that value, or you can delete that those values also. So it's up to you whatever you want to do, but this positioning by the use of rows and columns is known as subscript value. Okay. The second type of positioning is index value. Index value. So if I want to change a particular value here, let's say I want to change 9 here. What is the index value? 1, 2, 3, 4, 5, 6, 7, 8 and 9. Oh, it's 9 and 9 value also, 9 position also. Let me change the position, the value. Let's say I want to check the value of this, check the position of this value. 1, 2, 3, 4, 5, 6 and 7. The position is A7. A7, enter. Yes, it's 1. And if you want to change it, you just put equal to and let me change it to 100. Okay, so by using this kind of pattern that you are using A7, it could be A36. Okay, so you can write A36 here, 36, 36, and again the value 100. So I have changed this 36 value. So likewise 35, 34, 33. Every position you can just count and reach there what the index value of that matrix is. Okay, this is how you can get the position value and change it. You can delete it, whatever you want to do. We have just discussed how to get the positions of matrix by using subscript value, row vector and column vector values, and the index value is that position where this your value is situated. Okay,